What's up, guys? Thank you very much for being an electriker. I really appreciate. Okay, now as the title reads, this is automatic changeover switch tutorial. Now this time around we have everything we need, and we'll have to crank the engine automatically after assembling all these stuffs together. Okay, now this video is going to be long. Okay, this video will be long, but don't worry, I have put timestamps, okay, for you to be able to jump to a specific item that you really need. But because we want to embrace everyone, so if you know that you're totally a beginner, then you have to watch this video from right this beginning to the end. Okay, now let's jump into it. Now we've been doing changeover switch quite often. I have videos on the channel. You can, rush right there. I'll put some links in the description for you to be able to understand some things that I will not, stress enough in this video. Okay. Now, one thing you have to understand: changeover switch, automatic. The reason why we use them is because we want to switch between two sources of power. You might have your utility power supply and then the backup generator. And when that power, shades or ceases to be there, now the changeover starts the generator, and then the load then the load transferred from main to the generator. And then when the main comes back, the reverse also is true. The load is transferred to the main contactor, and then the generator will go to cool down and then go off. Okay? All right. Now, let us understand these components right here. Okay? Now, in this changeover switch, we have right here two contactors. These two contactors, one for main and one for generator. Now we have two relay, one for gen, one for generator. Okay, and we have two control breakers, one for gen, one for main. We have two timers, one for gen, one for main, and we have a phase failure for main. Okay, so as I've put them for you like that. Okay, so the other thing I want to to talk about is in this circuit, in this control that we are going to do, we are going to have DC power source, and the reason for that is because these two contactors, the coil is DC, and then these two relay, the coil is DC. It's only these three stuffs, the phase failure and these two timers are SC. Okay, so we need a DC source in our circuit. Now, what happens is with changeover of those kind is that you either have a transformer or you have a power supply of this nature incorporated in your channel. So that means that each side will have a power supply, because the power supply has to be powered from independent sources. If it's a generator side, it has to be powered on a generator. If a main side, it has to be powered on a main side. Okay? All right, and to demonstrate that, I did a video previously, which I'll put the link in the description and the info card. If you're interested, you can go watch that video. Okay, all right. Now here we are going to begin with the main. Okay, now we are doing two circuits. Okay, so we are going to do the main first, and then we do for gen. Okay, okay, now this is main, that is main circuit. So this is what we are doing. You have a timer, okay? And then you have these two contacts. This is closed and this is open, okay? And then you have this is common and is close to this, okay? Now, right now, from there we have our phase failure, we have our timer. Now, let's have the relay. Now, after the relay, we will have another contact here, which I will explain, okay? Now I need to show you something, so I will separate this. So that you can understand very well. Now, this is our phase failure, okay? This is the main control. This is our timer. And then here, this is a relay. Okay? And this contact here is gen, is NC gen, generator, okay? Then you have now the coil. This is the main contactor coil. Main contactor coil, MCC. Okay? You have to follow this because when we are doing the connection, I don't want you to go back and, you start meandering. So I want you to look attentively, okay? All right. Now, this is what happens, okay? So these are the components. You have here, you have a phase failure, okay? And then you have a timer, okay? And then you have a relay, and then you have the main contactor. Now, here, there is a generator contactor normally closed, okay? Here, there is a generator contactor normally closed. This is the main contactor. And here, this is the main circuit we are on. Okay? Hope. Now, let's simulate our circuit. So, we have our L here. You have your SC. Okay? Now, first, you have to understand that this is common, which in most cases, it is contact number 15 on the phase failure. This one is 16, and then you have 18, which is open. Here, 15, this is 16, this is 18, okay? This one, no worry about them. Okay, now let's simulate the connection. Now, first of all, from your breaker, this one, you will supply your phase failure. You see? Now, you will supply your phase failure. And now this phase failure, it has got contact number 15 here, which is this one. So you'll have to get power from here, and then you loop it because it's the same circuit, okay, up to here. Now 15, you have given 15, so we know that when this energizes, it gives 18. So now 18 will get power when this coil energizes, and then it will supply our relay, our timer. The timer is right here, okay. This is the timer coil, is inside A1 and A2. Now the contact is in 15 right here, and then 16, 18, okay. So we are going to give 15, which is common. Now from, you see, from this guy, will supply the coil. You see that? The coil for the timer, and at the same time you loop the same wire, you take to the common number 15 of this very timer. Now the timer, we only want number 18, which is normally open, which will close when the timer energizes. So we come to the relay, to the generator relay, okay, which is here, okay, and we will give the coil supply A1, and then we will loop, okay, here. Then we give contact normally open to the relay, okay, because when this relay contact closes, you see, when this relay contact, when a relay energizes, this contact closes. Now when it closes, it will go through the normally closed of the generator contactor now, okay. We'll go through the normally closed of the generator contactor, and now here it is, it goes to the generator contactor coil, okay. Now that then means that this is a neutral, and this is a neutral, and this is a neutral, okay. Now that has been step by step. So that's the control circuit for a main generator, or main circuit, or the main contactor. You're done, okay. Don't get confused, you're done. Now let's go ahead and now do the generator contactor, okay. Take note that you'll use it as a reference, okay. Now gen, okay, so with gen we have our timer first, closed. Now we have contact normally closed of the main relay, and now we have the relay now for the generator, and from here we have contact normally closed of the main contactor, and then we have the main contactor, I mean the generator contactor. So okay, now what I want you to understand, that This is a timer. Remember, we are on generator circuit. This is a relay main. This is a relay generator. This is NC main. Then this is generator contactor, GCC. Okay? Now let's simulate the circuit. Now, from your breaker, once again, you have now your L, which is connecting to the timer contact, and then you loop to, number 15, or to the common contact. Now, right here, when this timer closes, definitely it will close this contact. Now, this contact, before it goes any further, it has to go through the main generator relay contact, not contactor, contact. And now, through it, it will now go and energize the generator relay. Okay? So, when it energizes the generator relay, this is close. Okay? So, our contact here will get, power for the relay. And then this contact will close with this one. All right? And when this contact closes, this contact will have current, which will now go through the main contactor relay, and then from here, the main contactor relay, normally closed, will supply the generator contactor. So this is neutral, this is neutral, this is neutral. Hope you understood that. Now let me explain. Now, this is your circuit. You have a timer here. You have a relay for the for the main right here, normally closed. Then you have a relay for the generator right here. And then you have the main contactor, normally closed, right here. And then you have now the generator contactor, which we are controlling. Now, when you supply, remember, let me say electricity has gone, okay? The generator will get its signal, and I will show you where the signal comes from, okay? The generator get its signal, okay? Now, what happens is, when the generator gets a signal, generator starts, and when it starts, this timer here will get current, and it will get energized. So this is the current here. Now, when it gets energized, it closes this contact here. And this contact number 18, it has current because the timer is energized. So we use the main contactor relay, normally closed. That's where we take it through, okay? Now, after the main contactor relay, it will now then enter this relay, and it energizes this relay, okay? Now, we loop to this relay, of course, to normally open. Now, through it, we go and pass through the main contactor, okay, normally closed as an interlock, now to the coil of this contactor here, the generator, okay? Now, the reason why we pass through the main relay it's because we want the main contactor or the main power to be the priority. Okay, now assuming that right now the generator is running, and you will see that when we run our circuit practically. Okay, now assuming that the main the generator is running now. Okay, now if the main power comes back, remember, if you look at the circuit, the main power comes back, it will energizes this relay. Okay, and when it energizes this relay, that means that this contact where the supply for relay of main or of the gen gets power, it's cut off. Okay, so definitely this one will get energized, and this contact here will open. When it opens, the generator power is cut off automatically. So when the generator power cut off, remember, you will remember that the main relay also passes through the generator contactor in the previous circuit, the circuit we've just done. Okay, so when this contactor here de-energizes, it closes, the normally close of course, and then the main will just go in automatically. We will see that. Okay, so that's the reason. Okay, so I hope the circuit has been so simple. Now let us do what we call now the signal. Okay, so such that when we do now the connection, everything flows. Okay, most generators use closed signal. Okay, so you have to keep a certain contact on that engine short-circuited. So when that contact remains short-circuited, it means that the generator will be in auto. Okay, so long as that contact is short-circuited, the generator will keep on running. The moment you open those contacts, generator will go to cool down and shut down the generator. Okay, okay, gen signal. Now let us have a relay here. Okay, so this will be the main relay. Okay, the main relay. So in your circuit, in the main relay, okay, this is what happens. We are using the normally closed of the generator relay because they are the relay has a lot of contacts. Okay, so you remember that we explained everything on this relay. So you will have a signal cable here, okay? And this is one cable that goes to generator, okay? So the only thing we need is like that. Okay, so we just take this generator, the cable that we take from the generator contacts for auto or for signal, we just get that cable and we find a free normally closed contact on this relay, on the main relay, and then we connect that cable there. Okay, so when the power goes and this relay for the main, the moment it de-energizes, so it sends a signal to the main to the generator will crank. But when the main comes back, and remember, we have made it our circuit priority. The main is a priority. So when the main comes back, it will energize, and it means that this contact here will open. And when it opens, the generator will go to cool down. Okay? All right. Now, having said that, let us assemble this thing. We start wiring, and we see what happens. All right. Now, here is our components already attached on the rail. Now, from here, this section here is going to be our main, and then this section here is going to be our gen. Okay, this is a main contactor, this is a gen contactor. Now what we are going to do to make sure that this circuit is very simple without even any single confusion, we are going to wire the main part first, then after we wire the last one. Okay, now let's begin. Okay, now we have our wires here, many. Okay, now the first thing we are going to do, this is our breaker. Okay, so we need to get power from here to number 15. Okay, now our number 15 has got as per our circuit as we explained. Okay, now we need to supply our timer. Okay, so we just go to number 18. Now this number 18, it will go as per our agreement on the circuit. Okay, it will go to number A1, and then we also loop from there. Okay, now since our relay uses DC, okay, so we are going to give our relay from our power supply. Okay, so this is our positive from our power supply, because now the relay for the main, okay, uses DC, and the contactor also uses DC. Okay, so our DC is inside. Okay, now from here we need now to go to number 18 so that we can get current here, and then we pass it around. Okay, so we are going to pick contacts here from our relay here. This is the main relay. So we want to look at contact here. Now we can use contact number 6. So contact, if we look here, we find that contact number 6 is close to 5 and open to 7. Okay, so we're going to use contact number 6 here, and then contact the same thing we are going to do, because we want our relay to get energized. Okay, now our timer here, number 18, it has given us this. Now at the same time we are supplying our relay. Okay, so this is the A1. Okay, so I'm just going to loop it here. So guys, I'm just following the circuit that we've done. I'm not altering anything. Okay, now we give a number, contact number 6, and then contact A1. Okay, so what contact number 6 is open to 7. So we are just going to get a wire here and connect it to here. Okay, now our relay will get energized immediately because we've given it power from the timer here. Okay, but now this cable is going to energize the coil for the generator, but first it has to go through the NC of the generator contactor. Okay, so now this will go to A1. of this main contactor. Okay, so guys, the only thing we are remaining here is to connect the neutrals. Okay, so because the relay, the neutral uses DC and the contactor, so we are going to now run the neutral wire. Okay, so this is A2, we've connected negative here, and this is, we put it to a relay. When you're trying this, yours will be very easy because you're going to use throughout AC. Okay, now the only thing you're remaining with is to connect the power for the relay, I mean for the phase failure, and the neutral for the timer. Okay, now phase failure, because we are just going to use single phase. The control circuit is a single phase, you know that. It's only your power circuit that you can either use it on 3-phase or single phase. Okay, so we'll use a single phase. So the relay, I mean the phase failure, if you're going to use a single phase, we know very well that you use a P and you short one of the phases. Okay, and that's it. So we'll do it here. So we'll get our power here like this. And what we want to do, so this happens when you're using this kind of phase failure. All right, now what we have to do is now to connect the neutral for phase failure and for our timer. So this is our A2, because remember we are using AC and DC in this circuit. Okay, now don't worry about my wires, okay? Just follow. All right, now it's like we are done with the side of the generator, and what we have done, we've already connected our phase monitor, which supplies this timer here, and then the timer takes DC number 15, and then it outputs it number 18, then it gives it to the relay, relay coil, and also it loops it to contact number 6, which is open to 7 of the relay. Now that 7 goes through normally closed of the generator contactor, then it goes to the coil of the main. Okay, so let's go ahead and now do the gen side. So we are done with the main side, so we do the gen side. Okay, now the gen side, still the timer is AC, and the relay still is DC. So we have, I need to put this one right. Okay, get our supply here. We need a longer wire, so we'll give number 2 to energize the coil, and then we will okay, now what we are going to do is we are going to take number 3, because number 1 and 3 are open, number 1 and 4 are closed. Okay, so we are going to take, now you have to remember that from this timer we have to go through normally closed of the main timer. Okay, so we are going to go to normally closed of the normally open of the timer, and then we look for another closed. Now we can take number 1. Now number one here is closed to number 4. Okay, number 1 is closed to number 4, so we need that one. Now number 1. So we've given number 1, and then number 1 is closed to 4. So we are going to connect to number 4. And when we connect to number 4, that's when we will now supply. Okay? So we need a longer wire. Okay, like this one. We look for number 4. Okay, now this number 4 here, it can now go and enter, okay, the A1. So we need to loop it. Now we've given A1 of the generator timer because we are on the generator side. So what we are going to do is we are going to use number 6 of the generator timer. We are going to give it current. We know that 6 is open to 7, and that's what exactly we want. So 6 is open to 7. Now, this cable, it is intended to supply now the Gen contactor. So what we are doing is this cable, before it reaches here, it has to go through normally closed of the main contactor. Okay? Okay. Now, after the normally closed of the main contactor, we are now going to the coil. Okay? We can now give it to the coil. And because me, I'm using a DC contactors, so I have to be very careful of the polarity. That's done. Now, what I need to do is just to connect the neutral for the timer, for this contactor, and the neutral for the relay, okay? Actually, negative, not neutral. So we have a negative here. All right, now we are very much done with our circuit. So these breakers, as you see, they don't have cables in them because we need main power here, we need generator power here, okay? And we have a DC supply that I have showed you. Now, we've progressed well. So this is what we are doing. We have a power supply which is going to supply the DC components of the main, and then we have a power supply or a DC source on the generator which we are going to use to supply the DC components for the generator side. Okay? Now, I have finished this part for the wiring, so we are just going to the generator lobby, and then we grab a 10 kVA so that we can put our changeover switch at test. Okay, now before we go any further, this is a changeover that is done. Okay, so we have a Gen relay and we have a main relay. So on this main relay, as I said earlier, that's where our generator signal is going to be, and you will see as we go to the generator. So let's go to the Gen lobby, and then we have all these things connected together. Yeah, I'm so glad. Let's go to the lobby. Okay, now we are at the generator here. We have our 10 kVA right here and our changeover. Okay, and we build the changeover step by step, like the way you saw. So we showed the circuit diagram, and we explained it on the side of the main and then on the side of the Gen independently. Okay, I also explained that I have some DC components in here, the relay, the contactors, and I showed you how also that DC flows. Okay, now I have a power supply. I have a power supply here. This power supply is giving us DC for the main contactor, okay, and the main relay, okay, and this power supply, it's energized by the main power, okay. So if the main goes, this DC also loses power, okay. Now with the generator side, we have a relay which is, and a contactor which is DC, okay. So what we've done is that we are using DC from the generator, okay. We're using DC from a generator, not the twinkle charger. We are not using the power for or the DC from the twinkle charger. We are using DC from the battery, okay. We are using DC from the battery, but now the difference is that DC, to be actuated, it is supposed to be actuated by the timer, which is supplied by SC, and that SC is from the generator breaker here, okay, from the generator breaker here. So that's it. Now the other thing also we have to look at is what is remain is the signal cable. Now these are the two wires, the signal wire, okay. They are normally two wires, okay. Now this is a packing generator whereby contact 24 and number 5, contact 24 and 5 are the generator signal. So when you short them, the generator starts, okay. So I will link a video here which I explained how, to start, how to connect that. I will not show it here, okay. Now this relay for the main, this is where we are going to connect this signal cable, normally closed of this relay, okay. Now when I look at this relay here, the only remaining contact here is number 11, and if I look here, contact 11 is close to number 8, okay. So we are going to use contact 11 and contact 8. Okay, that is done. Contact 11 and contact 8, okay, and you will see that that contact is normally closed, okay, meaning that the generator will start working, okay. Now let's pop in our relay. First I'll put in our diodes. Okay, now we are all set. Our changeover is ready to be run, okay. So the first thing you have to do is we are going to turn our generator on because the ignition key was off, okay. Now like I said, you have to make sure that the generator is in auto and then everything is set here. So the first thing you are going to do is to make sure that our main is on, okay. Now we have our main here. Okay, so what we are doing now is to switch on this breaker. and this is our phase failure. It is trying to see if the voltage is okay. The timer is on, is counting, and the contactor for the main is in. So now we are being supplied power by the main, okay? So we have to make sure that the generator power is, everything is on set, okay? Now the generator, we are putting it in auto, okay? We have pressed the yellow button. So now here we are. This contactor is for the gen, okay? Okay. Now let's switch off this power, okay? Now the generator has started, the timer engages, and the contactor is in. Okay? So if the power comes back, let me switch back this. The timer is on. Now the contactor has come out to the gen and the main has gone in, okay? And the generator is in cool down, okay? So the gen will cool. Okay? So let's do that once again. Okay. Now our main is on. So what we are going to do is to switch off our main, and our generator is ready to receive. Now generator will go on, switch off. Then it starts here, and the contactor enters. Okay? And we switch back the main on. The gen is in cool down now. All right. Now hope you understood everything here. So I've tried my level best to give you the good view as much as I can. So that's how a changeover switch works. Okay, you've seen how we put together all the components and how we've wired them. Now in most cases you're not going to use any DC component. Then you make sure that the circuit for main takes all AC, the circuit for gen takes all, only gen power, main only main power. Okay, it will only the signal cable, it's the only cable that will come independently from the gen. All right, so thank you very much for watching. I really appreciate that. Please don't forget to subscribe, like and share if this video had some value. Okay, so until next time, I'm out.